Hello, right. Okay. How many of you? There's no bus service, am I right? Yeah. How many of you are like? How many of you like have to walk half an hour to be here? Okay. From now on, I mean I don't know what other prof does. I really don't care. From now on, until the strike is over, all lectures will be live. Okay, so you can be at home. Okay, and I mean when at home, really at home, sit down and listen. Okay, not like when is our final? Can you remember? December. December. Well, let's watch freaking YouTube video on December the 9th and tell him about it. I'll come after you. Are we clear? Okay, so if you guys are really affected by it, okay, or the walk, especially the weather, it's not going to be any more kinder. Okay, so from now until the end, until the strike is over, this course can be taken online synchronous. Are we clear? Okay, but try to show up if you try to show up if you can. Okay. I need to apologize to you guys first. Okay. I did not tell you this. So, Mr. Sailor Muhammad over here. Right? Yeah, got it right.
Yeah.
Muhammad Sailor.
It's okay, Mr. Salam, Mr. Muhammad.
Okay. He will be lecturing today, and I'll be a student today. The reason why he's going through a program at McMaster that he has to lecture for an hour. Okay, so he's going to lecture you guys. And I think it's good to listen to a different voice. I cannot stand my voice for 5 minutes. I don't know how many guys wait for 45 minutes, like 5 hours a week, okay? So, Mohammed will lecture today. Everything will be as normal. The diagrams are on avenue to left over here. And then I'll be a student and I'll be a dead one. Okay? I will sit somewhere and copy the notes. I've never been a student for 25 years. Don't stress.
Good afternoon, everyone. My name is Mohammed Salim. I am a operating group. So today is very easy. It's second law, Newton for motion, submission forces equal mass times acceleration. So it is easy. But first, I want to ask you questions. Why you study dynamics as a mechanical engineer? Does anyone know? Why you study mini mathematics to calculate velocity, acceleration, and if this body is rotating or not, the reference is fixed or relative, and the integration and derivative to calculate acceleration is hard for me. Why? Yes. You can take a picture or make a video. Why? As a mechanical engineer. Yes.
So you can optimize and save more money.
Optimize what?
Like let's say
So why is optimization for knowing velocity and acceleration?
you can design like a structure that does the same thing for one less area.
You are right, but you need the final step to your objective. To study structure and judge if structure is safe or not. But what is the step from knowing kinematics and ending by safe design or not safe? Let's see, you studied chapter 16, the position, velocity, acceleration. Good? What is the benefit from knowing velocity and acceleration as a designer? Yes?
body's motion.
Body's motion. By itself at first, the body is moving. But if you know the acceleration, and with direct application by second law, Newton's second law of motion, you can calculate summation force acting on the surface, which is external forces or internal forces. Good? What is the benefit from knowing the force?
Just an application of this. So if you know, let's say, that the velocity of a certain item is going at a certain rate, you can adjust maybe things like lubrication or something based on that. So the summation of forces can help us add modifications to the systems. If something's going at X rate, we need this kind of movement, this way.
You are 100% right, but this is too much complicated for me. It's easy. How to judge if your structure is safe or not? You apply load. If the load is too much, you will fail. If the load is not too much, you will be safe. How to judge that? You will calculate the stress or maximum stress which acting on the structure, and you compare with the maximum stress which the structure can handle. Good? So, the objective of your study is calculating the stress, and you compare to your stress or whatever your criteria, maximum stresses, and judge if your structure is safe or not. Good? How to calculate stress? Does anyone know?
Depends on the kind of stress. So like normal stress would be force over area.
Like say the basic equation of stress.
Force over area.
Yeah, you are right. Force over area. If the force is normal to the area, we call it normal stress, like a pressure. If the area is parallel to the force, we will be called like shear stress, like friction on the surface due to the flow of motion, the fluids. Good? I give this introduction because many of you ask about how to calculate stress in the exam number 2. The stress, simply force per unit area. Force divided by area. If the force is normal to the area, the stress will be called normal stress. If the force parallel to the area, we call it shear stress. Good? Our target today, how to use Newton's second law of motion, which is equal summation force equals what? Mass times acceleration. Good. In general equation, in general position, we have a rigid body acting by forces F1, F2, F4, F3. This is forces. Cool what? What is the name of this forces? I don't know. What external forces. So, if you study the forces from respective the boundary of your system, so the forces or moments called external. Good? But if you divided your rigid body to many parts and you study the internal forces or internal moments is called internal moments or forces, or another concept called reactions. Good? So according to Newton, the summation force in a specific direction is equal mass times acceleration. So summation force, for example, in x direction is equal MEX. Summation force in y direction, we have x and y domain, MEY. So EX, EY, summation force in x direction, summation force in y direction. So this equation is a scalar or vector? Vector. So if you have a 3-dimension problem, you can apply this equation how many times? 3. X, Y, Z, T, Z, and T and N, which is if you rigid body moves through a circular path, you have a tangential direction and the normal direction. Good. What about moment? Summation moment. When you forget what is the moment is the torque. Forget as a sign, like say summation moment equal what? Maybe. Have another answer? Yes. What? Excellent. Excellent. Yours a new TA. Very good. Something called I, second moment of inertia, as you told. I don't know. Times what? Angular acceleration. How to expect that? Summation force equal mass times what? Acceleration. In a rotation, which causing by the torque by the moments, the acceleration converted to angular acceleration, which is represented by alpha. And I, it represents the resistance for rotation, which is equal, it's called second moment of inertia, which depend on what? The mass. So the mass here and second moment of inertia is represent your resistance, the system resistance for moving in a linear path or for rotation about fixed axis. Good? But for mathematics, that's about the center of gravity. The acceleration and second moment of inertia is calculated around what? At what center of gravity. So we have Ex, Ey, or Az, if you have a 3-dimension, yeah, and second moment of inertia at a point G, which is called center of gravity. Good. So we can draw this rigid body. We have here the masses in x direction, the forces in x direction, and this is G. And here the forces in y direction, and we have the total moment, which is equal Ig times alpha, which is represent angular acceleration. If you have a point B, is not G, and I want to calculate the moments around B, how to calculate that? Yes.
Parallel axis here.
How?
I plus md squared. I think so. The mass times the distance from.
Yes. So you can return to the original problem, and for a specific force, you can calculate the summation force, the summation moments for all forces around B. That's right. Good. Or you can calculate the moments due to what? The resultant forces at G, which is equal like max. If we see this is y bar, and this is x bar, and this is your axis at point B, it will be minus max y bar plus may x bar plus ig alpha. Good? The left-hand side is called the kinetic moment around B. Kinetic moment around B is equal to ig alpha plus the moments of mag around B.